Intro chat with Merrill's live, digging deep where techs thrive. From the latest hacks to cool updates, join the ride, don't be late.
Hey, hi folks. Welcome to another episode of Entra Chat. And today I have Simon joining here with me. Simon had a really interesting project that he shared on LinkedIn, and the repository is on GitHub. And I was really fascinated with all of what he's doing there. And as a DevOps person, I was really keen to learn more about this and dig deep into it. So Simon, why don't you tell us about yourself, what you do, and then we can jump on into all this nice stuff that you've been working on.
Yeah, of course. Thank you for having me. My name is Simon Gottschlag. I live in Sweden, Gothenburg, and I'm the CTO of CoNative, a group of cloud specialists with four firms. We have Azure, BuzzCloud, Elasticmove, and Zenit. I was the first employee at Zenit, started working around 2009, and I've been a consultant since then. I think I've been an MVP since, 2023, and with a focus on Azure. And I have a background in operations, infrastructure, application delivery. And but the last couple of years, I also learned how to code and find that a lot of fun.
Nice. Awesome. All right. So let's jump into the project, right? You call it a prototype for implementing Azure Service Principal Impersonation using Azure Functions and Key Vault. So let's talk about like what's the problem space here, but what are you trying to solve with this?
So perhaps we should start from like where I come from, so we can understand why I find this fascinating and fun thing to work on, perhaps.
Yes.
So if we go back like 10 years, I worked a lot with application delivery and identity federation. And this was perhaps before Azure AD and Entra was like the best player. And we had a lot of other technologies that did work quite well. And back then I was a consultant doing a lot of Citrix NetScaler. And we protected applications using load balancing and OAuth 2 and all that. Worked a lot with Azure Active Directory Federation Services, ADFS, and built a couple of custom federation gateways. So that's from where I started, and I've been working with this technology for a while, meaning I don't find the actual technology of OpenID Connect, OAuth 2, JWTs, it's nothing new. So when we started to get these kinds of things in Azure, I started to experiment quite a lot. But before we go to like why do I want service principal impersonation, perhaps we should look at like the journey to reach that point. I think it started, let's say, somewhere around, 5 years ago. I started building platforms, both internally and for customers. So we built, let's say, a Kubernetes platform for customers to use. And that meant we had to create a lot of resources in Azure and Azure AD. And we did that using Terraform. And one issue we always had back then was that if we wanted to use Terraform to create service principals, we had to grant either the highest permissions of all, which really doesn't fit well with least privilege. So the only thing we really could choose was the permission of, I think it's called application read write owned by, which we could assign only to specific service accounts or service principals.
Yeah. So let's just to recap that little, right? So in Microsoft Graph, if you have a service principal, and with Kubernetes, what happens is you need to spin up a lot of service principals for it to work for each of the different nodes. So in a DevOps pipeline, you can't have people coming in a usual Entra admin sort of model. If you want to create any service principal, like in an enterprise, what normally happens is someone has to submit a form with a request saying, I need this service principal created for this purpose. And then the request goes to the Entra team and they action that one service principal and they give access. Right now, in places where I worked before, it would take like sometimes weeks to, just to get one service principal provision, because you need to show why you needed it. You need to have all your paperwork and all of that.
Exactly.
But with Kubernetes, you're like creating a lot, right? Sometimes like hundreds of service principals a day, depending on how much work you're doing when you're the way the clusters work and so on.
And in our case, it's not only for Kubernetes. So when we create something like an Azure landing zone, we want to create service principal for each subscription perhaps, and have that service principal connected to a repository. So the consumers of the landing zone can securely connect to their resources and create their resources using infrastructure as code as an example. So
nice.
Creating these service principles has been a part of like what we've had to do for a long time.
Right. And so the usual model of submitting a request and waiting for it to be created, like that doesn't work. Like you can't do any DevOps if you were to do that. And you need an automated way for one service principal to create other service principals.
Exactly.
And this has always been the challenge. So someone tries to go write an automation and you go look up the graph permissions. For a very long time, you had to give that service principal application.readwrite.all, which means it has like almost like a global admin privilege, because if you can do that, you can grant like, any permission to any user, right? You can grant a global admin role to a user as well, because that's what the app read write all permission can do. I think in Bloodhound, they have this attack path and so many others that show how with app read write all, you can do a lot of harm. So we have this other permission called application.readwrite.owned by. So it sort of limits the scope instead of being able to give or write or manage other service principals, like any service principal. You limit it to only the service principals that it created. So you sort of limit
that it's specified as the owner
as the owner
created. Because I've done that mistake a couple of times. Create it without setting the owner.
Right. Yeah. You need to go to the owner and then you assign the owner, and then you can limit the scope to just the service principal that you own by. Right. Yep. Sorry, continue. So that's just setting the stage for people.
Yeah, it's I love it. Please continue to do that. So, but building these platforms, this was like one of the bigger issues, because as a developer of a platform, you want a good developer experience. So developer experience in this case is building the infrastructure as code that creates the platform. And now we have a service principal that is required to do the Entra stuff. And that meant that we couldn't do all the things in the dev or in the dev environment in our case from our local machines, because then we had to run it as that service principal. And that meant you had to bring a client ID and client secret and have that on your machine and then remove it when you were done. And you do have some kind of auditability of that, but it's not a good practice and it's not a good experience either.
Yes. And over time, what happens is when you use like one service principal to do a lot of things, you lose the least privilege model, right? So you go the other way where you start giving one service principal lots of permissions into Azure, into lots of services and resource groups, and you are now no longer in least privilege world. So it's not an easy decision, right? You have on the one hand lots of service principals with least privilege, or one service principal which you can manage, but then it has a lot of permissions. It's a fine line when you need to walk that.
For sure. And what we've always tried to do is make sure that the people managing these kinds of platforms should be able to have the same permissions as the service principal. So like if they need to run, in this case, Terraform locally, they should do it as themselves. And at least in the dev environment, that should be possible to enable a good developer experience. But that's not possible when we are required to use a service principal to create the other service principals in this case.
Correct. Yeah.
And another issue with that is we can't make a specific group an owner of the objects in Entra. So that means that, well, the only way to actually run this fully is by using a service principal. I think that was kind of like the first time I found this issue. And that meant we couldn't really tell people that if we came in to a customer and told them, oh, we are going to set up this platform for you, we now require these specific permissions, but those specific, either we ask global admin and then we do everything, but that's not a good thing, right? So we had to like specify, we need these permissions to be able to set up the platform and maintain a platform. And that meant also, for now at least, that we needed that service principal with its permission and we needed to use it. But a lot of customers doesn't allow us to actually use a service principal locally. And that then becomes the problem of like, okay, how do you develop this platform? You do a pull request, you merge the pull request, and you see if everything works. And the developer loop becomes quite bad.
Yes. So, yeah. And just for context, when you say platform, you're talking about some VMs, Kubernetes, whatever in Azure that you're creating.
Exactly.
Right? Resources.
The platform in this case could be we provide developers Kubernetes as a service, or we're like on top of Azure Kubernetes service, or we provide a landing zone vending machine for a customer, like those kinds of platforms. So we have a product that we provide them on top of Azure. And that could be lots of different things. It could be Azure Virtual Desktop as well. But those things are what I usually see as the platform.
As a platform, right. And you work for a product company, but there could be others who are in the enterprise itself facing the same challenge, right? Because they've automated Terraform, or there are the dev teams that want to spin up lots and lots of resources in Azure, and you need a way to give them access and where they can do DevOps to spin up those things, destroy them, create new services. But you need a way to grant those permissions in a safe manner. Yeah.
And a platform is like if you look at an enterprise, they usually have platform teams providing different kinds of platforms for their internal customers.
Correct.
And that's like when I work with these things, I usually I'm a part of perhaps a customer's platform team or something like that. But let's see. So how did I come up with the idea of actually doing service principal impersonation then? Well, I've been working with customers where they require 4 eyes principles. And I'm not sure if you've worked with it, but it's about whenever you do something, you need an approval, someone else to say that it's okay. In Git, that would be someone reviews your change and approves that change. In Azure, if you want to like be an administrator for a couple of hours, that's PIM, and using privileged identity management to become an admin for a couple of hours perhaps. But you need someone to approve that. And not a problem with that, but a challenge with the 4 eyes principle is that if we grant people in Azure the permission of owner on a subscription, that means they will be able to give themselves or other people permissions when they are owner. So we need to like give them owner-like permissions in Azure, but not exactly owner. And in our case, we figure out that using attribute-based access control, or ABAC,
ABAC,
we can actually create, perhaps, let's say we have an internal customer. They get a group, and they can use PIM to access that group. And then we can also use ABAC to tell them that they and their own service principal can delegate access to that group, and only that group, and they can only delegate specific permissions. That could be like storage account contributor, or something, metrics publisher, or whatever they need, like.
Yes.
And
so just for the listeners who are listening in who have not heard of ABAC before, attribute-based access control. So we have the traditional model is role-based access control. So you assign a role, like contributor, reader, writer in Azure. So you have those permissions which you are just given a role and you have access. How would you explain attribute-based access control to someone who's like never heard of it before?
It grants a limited scoped permission to someone. So in this case, we can grant someone in an Azure subscription the permission to delegate permissions to others, but others could be one group and one service principal, and not everyone, or only service principals, or only groups, or only users. Like ABAC allows them to say that you are allowed to use delegate role-based access control to this person or this group, and you are allowed to give this group this specific role. That could be like, you are allowed to give reader to everyone, but you're not allowed to give contributor to everyone. That could be one thing.
Yeah. And it uses the custom security attribute feature in Entra, right? Like where you can attach an attribute to the objects.
I think so. I'm actually not sure exactly how it looks in the background, but what you do is when you grant role-based access administrator, you can add like this new policy language to that role assignment, and create that ABAC configuration. And that enables us to do a lot of new things. And
it's a lot more flexible, right? Like it's not like a one-to-one. You don't have to go, say you have a huge complex Azure setup and you have various resource groups. Say one common example we use is, say you have HR related resource groups in Azure and you have finance related resource groups. You can actually tag them with that attribute to say these are all HR. And you can then say grant access to, like, Simon works in HR, so he can contribute access to anything in HR, but not to finance resource groups. So I
haven't tried that, so I'll take your word for it.
That's sort of how it's defined. So you can, instead of manually assigning attributes, you do an attribute. That's why it's called attribute-based access control. So you can tag attributes, and then people will just automatically get access by defining the policy, saying, these attributes, if it's there, give this person access.
Well, that's, as you see, I've only had a limited exposure to the feature, but the exposure I got was a really good one. And the great thing here was that when we now create landing zones for people in Azure, we can actually enforce that they are allowed to delegate some roles to themselves. That means that they can now, instead of having to use SAS keys on a storage account, they can use Entra Authentication and delegate that specific permission to themselves. But instead of delegating it to their own user, they delegate it to that group that they are required to use PIM to access.
Right.
And then we can also make their service principal that they are using from the pipelines, an example, a member of that group as well. So when that service principal delegates something, it also delegates it to that group. So we like enforce everything to go to that specific group, and that group is only accessible by either either PIM or that service principal.
Service
So
principal.
now we can enforce this 4 eyes principle on everything. But we've been using this for a while, and it's been working quite well. But
So just to take a step back, so you're saying the service principal, even though it's in the group, until the user does the PIM.
So we have to split up. So when they are using the service principal, they do it from GitHub or GitLab or Azure DevOps. And to use it, we enforce 4 eyes principle on the repository. So that means they can't use the service principal without 4 eyes. And if they want to themselves to get that permission, they need to use PIM.
To PIM, use PIM before they can even go and run the GitHub action or the Azure DevOps.
In this case, it would be to log in to Azure and make changes to something in Azure. So the service principal is always allowed, but they can't use the service principal without 4 eyes, and they can't use and they can't get that permission themselves with their own Entra identities without PIM. So we have like 4 eyes on both levels, and that's quite nice. But now, if we go back to the question of, I want to be able to run everything locally. Like, I want to be able to run everything locally while still adhering to these principles. How do we do that? And that was kind of the question that came up. But perhaps before we go into exactly why we started doing or looking into service principal impersonation, what actually happened when we started doing this in a larger scale is we see that everyone needs to use PIM all the time. So by that, I had the idea that perhaps we can do PIM through the CLI. So created an open source tool called PIM CTL that you can use to actually both request and approve PIM requests for Entra groups. You can do it for Entra roles and Azure roles. So that's like the first step of starting to building on this idea. And I created like an alpha version of it. It works. It's not something I would call production ready, but like being able to test out the idea. And then something else happened, let's say a couple of weeks ago, perhaps a couple of months ago. And that was a colleague of mine started creating Azure Managed Grafana. And Azure Managed Grafana also makes it possible to log in to the Grafana using Entra. But the Grafana provider in Terraform didn't support Entra authentication. So when running Terraform, we couldn't do things inside of the Grafana instance we created. And we wanted to do that. And the idea I had was like, Golang, the programming language Go, has really good support for all different kinds of authentication to Entra. And I thought, I've been using it for quite some time with PIM CTL, but with other tools I've built as well. I thought, shouldn't we be able to just build a generic thing in Terraform that makes it possible to like get tokens from Entra? And that's how the AC identity Terraform provider was created, because Terraform now have released a feature called ephemeral resources. So they are run both at the plan stage and at the deploy stage and are never stored in the state. And that now means that we can have a resource that we say is Azure CLI or the default credential, and we can point to a specific scope. So an Entra app, like I want a token for Azure DevOps, or I want a token for Managed Grafana. And by using that, we now enabled us to actually get tokens from arbitrary resources using Terraform with the current identity you're logged in with. And that solved like the Managed Grafana scenario, but that also opened up a lot of new possibilities. Like, what if we were able to, in a secure and auditable manner, get like a service principal token and use that for everything in Terraform? And that's kind of where the idea of, well, can we in any way use our current identities, like Simon Gottschlag, and when I'm logged in using this Azure CLI, can I get a token for a specific service principal without having to create a static secret? And I think this is where we come into the question of like, what is impersonation? But let me just take a sip of coffee. So in this case, like we now had a way from at least for me, from the CLI to become a member of a group. I have a way of getting all different kinds of tokens inside of Terraform. And the only thing I needed was like a way for me to exchange my current Entra token for Simon to a service principal token.
Service principal token.
But like that's not possible today because like Entra doesn't allow that. And perhaps in the future that will be possible. I'm not sure, but it would be a cool idea.
A neat feature, yes,
Yeah.
definitely.
But then like all like I've worked with this technology for quite some time, and federated credentials in Azure has been supported, and in Entra has been supported for quite some time as well. So I thought, well, what if I build something small that can take my current token, like my identity Simon, and exchange that to a token that I can use to identify that I am allowed to access this service principal. And how should that be done? And like when I'm logged in with Azure CLI in any way, I can always get my tokens. So, and I can use these tokens easily with an Azure function, and the Azure function can like validate you're from the correct tenant, you're within the lifespan of the token, but it can also verify things like you are a member of a group. And the idea was quite simple. I can send the object ID for a specific group, and it checks, am I a member of that group or not? And if I'm a member of that group, it gives me a token that's signed by a key in Azure Key Vault, and adds the subject of that object ID for that group. And if I now have a service principal, either a user assigned managed identity or a normal service principal, I can add a federated credential that points to my Azure function, so it trusts the public keys of that now slim OpenID provider. And I can tell it that if someone comes in with a subject that is that group's object ID, you should allow them to issue tokens as you. And like that was the idea. And I thought that shouldn't be that hard. I usually like code in Go, but I've had the pleasure of trying out C# lately. So I thought perhaps I should write some C#, and that's what I did. So I wrote an Azure function that authenticates the request. It looks at the current user and sees, is this user a member of the group that user requested? And if it is, it issues a new token signed by itself. And then the user can use that token to do a token exchange with that service principal. And now it is the service principal. And if we make sure that we have the correct audit logs in Entra, we can now have a full audit trail that Simon Gottschlag have impersonated this service principal at this time.
Right. Nice. That is neat.
Then we can use Terraform and the AC identity to actually do this token exchange for us. So like if you run it as a service principal, you do it one way. If you do it as the user, you do it one way. And you have a Terraform workflow that works good locally,
right,
and it works good in a pipeline.
Right.
And now you also have a good developer experience.
Yeah, as a dev, you don't need to change anything.
Exactly.
And your experience sort of stays the same as well, right? Like on the desktop, it's the dev just signing in. But then after the token exchange happens, it's actually running as a service principal. And that's exactly how it'll run when it's running inside the DevOps pipeline.
Exactly.
With the same identity.
Yeah. And if you require 4ICE principal, you require the user to use PIM before they can run anything locally.
Right.
And so and the circle is closed.
Nice.
So that was kind of the idea, and I created it. It worked better than expected. It's like something that I've wanted for quite some time is now possible to do. It's kind of possible since before in the other cloud providers, but now we can also, at least with some custom coding, build the same functionality in Entra and Azure. And that's super neat.
Nice. That's definitely something useful. So you also mentioned you have and this is all in GitHub, right? So we'll share.
Yeah, everything I've talked about is open source.
Is open source. You released with MIT license as well. So how would someone set this up? So I can see you've said that you do need the CLI, you need Terraform, and the Azure function. So you have to deploy the Azure function, right? Because it uses the identity of the function.
Yeah. So first, the disclaimer. It's just a prototype. If anyone wants to try this out, feel free to try it out, but don't use it in production because the code isn't written to be production ready. It's just a prototype. So I don't want to take responsibility if I've left some bug there. But what they can do is they can clone the repository, and then they can run the Terraform code in there. And then they will have that Azure function and key vault set up for themselves. And they can deploy the Azure function from the CLI as well. And then they will be able to actually try it out and use it. So we have a full example in the repository how they can try this out.
Right. So you need to create a group and assign the group that's configured in the.
We have a couple of test groups in this case. So if they want to just try it out. But the Terraform itself, it creates some things in Azure, some things in Entra, requires perhaps high permissions in Entra to do these things. But if you know Terraform, you will be able to figure it out quite fast, like how the different things are connected. But the whole idea is that you have this one group that you then request a token from. And you get the token with that group's object ID as the subject. And you can then use that to do a impersonation or token exchange with a specific service principal or user-assigned managed identity.
Right. And so one example is, of course, the DevOps automation that we spoke about. In your use cases, you also said temporary access, like do a time-limited access to service principals. How would someone implement something like that?
Then instead of being a permanent member of that group, they just use PIM to become a member of that group for a specific time period. Right. So that you leverage PIM to limit how long someone can do that. And then you can add these approvals as well if you want.
And then the Azure function will only work once, right? Like to give them the token, but if the time, it can check
the current implementation makes sure it checks graph every time you do a request. So it doesn't look at your groups in the token. It actually goes out and looks at your object in Entra and in Graph to verify that you are a member of this group. So that's my implementation of it. I haven't implemented service principal impersonating service principal, but that is possible as well if you want to.
Right. Yes. Yeah. Nice. Awesome. This is such an amazing, like the proof of concept itself, and just the idea of being able to do what you're doing, right? Like going from a user and then having this middle tier that you built, which does the work of checking and then giving you access to a token. I think that same concept can be used in lots of different places as
For
well.
sure. And like, let's say you are a multi-cloud user, you could then, when you are impersonating a service principal, you could use its token to do a token exchange with another cloud and like start building these multi-cloud deployment. Like there are lots of really cool things that these kind of patterns enable.
Yes, yeah, like you could, if you use this with the federated credentials, like you can then have that managed identity in Azure, having access to resources in AWS
Exactly.
and Google Cloud as well,
Exactly.
without any secrets in that whole
Exactly.
flow. And just from the command line, they'll be able to get access to those resources. Awesome. Excellent. Thank you so much for making this and making it open to the world. I think
Yeah, no
like
problem.
it's projects like these that help others build on top of each other and, build solutions where you can really extend Entra and out of the box capabilities, right? Like you don't need to wait for Microsoft to develop all the features. The APIs
Exactly.
are there and we can start building on top of what's already there. And that's an area I'm always fascinated about. Like how can you extend Entra to do new things, which you can, instead of waiting for all of the features to come from Microsoft. There is, of course, the risk because it's a unique thing that you're building. It's not the same sort of battle-tested solution, but that's what open source and sharing and getting more eyes on it and
Exactly.
building on others' work is what comes in super useful. Your PIM control is also, what do you call it? PIM CTL?
PIM CTL.
Cuttle.
PIM
Yeah, just like the
CTL. Oh, it's the same conversation as this is Cube CTL or Cube
Cube
CTL.
Cuttle.
Sorry.
Right. You have the PIM Cuttle, which you can use from the command line to do the PIM requests and approvals. Nice. That's a very interesting one as well. We'll add the links to all of those in the show notes as well.
I'll send them to you.
Awesome. Thank you so much, Simon.
Thank you.
Thank you for coming and sharing your knowledge with us. For anyone who needs, we'll share the links over here. And if anyone needs to try it out and run into issues, they could just work on open an issue on the GitHub project and help you. Cool. Awesome. Thanks a lot.
Thank you for having me. It was a pleasure.